Example 5 says, from 1950 and projected to 2050, the percent of women in the workforce can be modeled by W of x is equal to 9.42 plus 8.70 natural log of x, where x is the number of years past 1940. If this model is accurate, at what rate will the percent be changing in 2020? So the first thing that we need to do is we need to find the derivative of the W function, and that is going to equal 8.70 over x. And it's specifically asking about 2020, which is 80 years after 1940. So we would evaluate W prime of 80, which is 8.07 over 80, and that is equal to approximately 0.108. So in 2020, the rate will be changing by about 0.108% per year. Let's talk about the change of base formula. To express a logarithm base a as a logarithm with a different base, we have that. So let's say you had log base a of x, and you wanted to rewrite that using a different base. And I'll talk about in just a minute why you might want to do that. But this can be written as log base b of x over log base b of a, and that also includes any base b, which also includes base e, so we could rewrite this as the natural logarithm of x over the natural logarithm of a. Now, why might we want to do that? There's a couple reasons. The first one is we've only really learned derivative rules for the natural log, so we might want to change something to a natural log in this form here. But also, a lot of calculators will only have buttons for the natural log and the common logarithm. So let's say you wanted to evaluate log base 5 of 625. Now, if you look at your calculator, a lot of calculators don't have a button for base 5. And so you could rewrite this as the common logarithm, log base 10 of 625 over log base 5, and then you could get your answer that way. And this is also equal to the natural log of 625 over the natural log of 5. And all of these are equal to 4, and the reason that is because 5 to the 4th power is equal to 625. So this was just a side note as to why we might care about the change of base formula. And again, also, we will need it to take some derivatives. So let's go ahead and do that. Example 6 says, if y is equal to log base 3 of x squared plus 5, then find dy dx. So I'm going to rewrite this using the change of base formula as the natural log of x squared plus 5 over the natural log of 3. And I'll rewrite that as 1 over the natural log, so I'll have a constant times the natural log of x squared plus 5, like that. So now, if I'm taking the derivative, I will leave the constant out, so 1 over the natural log of 3 times 1 over x squared plus 5, and then we need to use chain rule and multiply that by 2x. So our derivative function would then be 2x over the natural log of 3 times x squared plus 5.